Hello and welcome to Deeksha Karnataka YouTube channel in the Masterstroke of PU1 chapters. Today is the last theory chapter, theory discussion, and today we are going to discuss the last remaining two PU1 chapters, simple harmonic motion or oscillation sometimes you call it, and waves. So these two chapters we have to discuss, and what are all the chapter highlights. In simple harmonic motion we have periodic motion, simple harmonic motion examples, time period in different cases. So this is the important concept. In waves chapter we are excuse me, in waves chapter we will be discussing what is the wave, what are waves, okay, equations of wave, different quantities related to waves, speed of sound, and we are going to discuss standing wave as well as organ pipe. Organ pipe is very important. We will also discuss briefly about beat frequency and resonance after organ pipe is over, because resonance is, even though conceptually resonance is not there, but you have to understand the meaning of resonance, because it is one line is mentioned in your NCERT textbook, and based on that simple resonance based question might come, and if you do not know the term you might not be able to answer those questions. So without any delay, let us start with today's session. First chapter is simple harmonic motion. Namely, it is an easy question, so solve it. Now let's move on to the next chapter, oscillation. First question: a particle executing SHM has maximum speed of 0.5 meter per second and maximum acceleration of 1 meter per second square. The angular frequency of the oscillation is. So we know that maximum acceleration is what? Maximum acceleration is a omega square. There is a negative sign, but we will ignore the negative sign for this problem. Maximum speed is what? Maximum speed is a into omega. Now it is given maximum acceleration is 1 meter per second square and maximum speed is 0.5. They ask you what is the value of omega. So you have to find omega. How to do that? Very simple. You divide these two, AM by VM. If you do that, you will realize everything will cancel except omega. Okay, only omega will left. So that means this is equals to 1 by 0.5. okay, this is 1, this is 0.5, so you just put the values. So this will be 2, so omega will be 2 radian per second. No pi is there, okay, no pi is there, pi will not automatically come, okay, so it will be 2 radian per second. Next question: two simple pendulums A and B are made to oscillate simultaneously, and it is found that A completes 10 oscillations in 20 seconds and B completes 8 oscillations in 10 seconds. The ratio of the lengths of A and B. Now we know that again time period is given by 2 pi square root of length divided by gravitational acceleration. So time period is proportional to square root of length. Okay, so if you can find the time periods of these two pendulums, you will be able to find the ratio of their lengths. Okay, so time period of pendulum A divided by time period of pendulum B will be simply square root of length A by square root of length B, that is length A by length B is actually square of TA by TB. Right, now what is TA? So for that, in the question it is given in 20 seconds it complete 10 oscillations. So time divided by number of oscillations. Remember, time period is a time. Okay, so time divided by number of oscillations will give you the time period for A, and for B again it completes 8 oscillations in 10 seconds, so it will be 5 by 4 seconds. Okay, so it will be 5 by 4 seconds. Now put the values and calculate. So LA by LB will be given by 2 divided by 5 by 4, and there is a whole square, so this 4 will go up, 8 by 5 whole square, so it will be 64 by 25. So correct answer is 64 by 25. Make sure you always, in case of ratio based question, this is my number one advice, always make sure the order is perfect, otherwise you will make mistake. Okay, so order is A and B first, A and B first. Next question: piston is performing simple harmonic motion in the vertical direction with a frequency of 0.5 Hz. Okay, a block of 10 kg is placed on the piston. The maximum amplitude of the system such that the block remains in contact with the piston. Very intelligent question, but again intelligent questions will be difficult for you, right? So what is this question is? So basically it mixes simple harmonic motion with the lift motion. If you remember, in a lift motion, when an object is standing over here, okay, suppose the lift is accelerating, some lift is accelerating downward, mg is downward, and there is a reactionary force. If you remember, reactionary force was mg minus ma. Okay, so it is g minus a into m when the lift is accelerating downward. Now here what happens, suppose the piston is like this. This is the piston. Piston means object which goes up and down. In case it is there in your engine, any car engine generally have a piston which is oscillating. Okay, this is not a linear motion, slightly complicated than that, but imagine a simpler version of that. Okay, it goes up and down like this. So it is simply, it is oscillating in this direction. Okay, up and down motion. Now at the extreme position, when the amplitude is actually equals to a, so suppose this is the amplitude. At this extreme position, when the piston is at its extreme position, the acceleration becomes maximum. At this position, if the acceleration of the piston, that is maximum acceleration of the piston, is exactly equals to gravitational acceleration, then the object will stay with the piston. If the piston accelerates faster than the gravitational acceleration, then the piston will start falling faster than the object can. Okay, so object will fall slowly, but the piston will accelerate faster, so it will no longer be on contact. So reactionary force will become 0. So basically reactionary force becomes 0. So if you see that, it will be G equals to A. Okay, if reactionary force becomes 0, then gravitational acceleration and the acceleration of the object will be 0. Now in case of lift motion, the maximum acceleration is obviously in downward direction is this. Okay, and that is called free fall. The object or person standing inside the lift will be in the motion of free fall. But here piston can go faster than gravitational acceleration as well, and if it is going in that acceleration, then the object will no longer be in contact, no friction required, only the concept of acceleration is sufficient. So we can say that the maximum acceleration of the piston must be equals to gravitational acceleration. Now what is the formula for maximum acceleration? Maximum acceleration is A omega square. Okay, right? So maximum amplitude will be G by omega square. Okay, now what is omega? Omega, here omega or angular frequency is 2 pi into frequency. Frequency and gamma sometimes can be same. This is frequency. Okay, so frequency of the piston, frequency of the motion of the piston is given here 0.5. okay, Hertz. Okay, so omega will be 2 into pi into 0.5, that is pi. Okay, so pi radian per second. So now put that value over here. G is 9.8 and omega is pi. Pi means 3.14. Okay, omega is pi. Right? So put that. So 9.8 divided by 9.256. Okay. Now this is very close to 1.09. This will be very close to 1.09. Now if you don't understand why it is 1.09, at least you can understand if you ignore 0.8 and 0.25, 9 by 9 is equals to 1, right? So the closest result for this value will be 1. Okay, and in the option only one closest option is given, that is 1. It cannot be 1.5. Okay, for it to be 1.5, it has to be 6. Okay, of the order of 6. Then only it can be 1.5. Otherwise it will be 1.09, which is close to 1.1. That means the correct answer will be 1 meter. Now next question, a tray of mass 12 kg is supported by two identical springs as shown in the figure. Okay, when the tray is pressed down slightly and then released, it executes simple harmonic motion with a time period of 1.5 seconds. The spring constant of each spring is. Now normally when we have a spring and if we have a mass spring system, suppose the constant is k, mass is m, the time period is given by 2 pi square root of m by k. Right, this is the normal formula for time period. But here instead of having one spring, we have two springs. Now if springs are connected like this, okay, if the springs are connected like this, suppose this is k, this is k, okay, the spring constant gets added, the equivalent spring constant. They actually behave like parallel combination. Springs are actually behave like parallel combination of capacitors. Okay, here it is parallel combination. In series combination it will be 1 by k equals to 1 by k1 plus 1 by k2, but in parallel combination it simply gets added. So total spring constant will be 2k. So total spring constant is 2k. Okay, now what is time period then? Time period will be 2 pi square root of m by 2k. Now obviously mass is given here, okay, mass is given here, time period is given here, so you just need to calculate the value k. So time period is 1.5, time period is 1.5 equals to 2 into 3.4. okay, so now from here we are putting the values. So t is 1.5 second, 2 into 3.14, mass is what given here, 12 kg, and by 2k. So obviously it cancels, we get 6 by k. So 1.5 into 6 not into, equals to 6.28 into square root of 6 by k. Okay, or square root of 6 by k equals to 1.5 by 6.28. Now this will be slightly more than 1.4. So if this number is 6 only, then 1.5 divided by 6 is 1.4. 1.5 into 4 is 6. So that means it will be 1 by 4. But here this is slightly more. We are obviously we are not expected to find the exact value. We are not using calculator, so we will try to find as close as possible. Okay, so we will take it as 1 by 4. Now take the square on both sides. We get 6 by k equals to 1 by 16. Okay, so k will be equals to 6 into 16, which is very close to 96. Now again, if you see that none of the answer is close, because obviously this value is slightly more than 4, so this will be slightly more than 96, and from the option, the closest option will be 105. So more than 96 is 105. None of the answer is even coming close, so it will be 96 Newton per meter. Okay, so that this is the spring constant of this spring. Remember, springs behave like combination of capacitors. Parallel means add, series means inversely add. Okay, now next question. A pendulum oscillates simple harmonically if and only if. A pendulum means simple pendulum which oscillates. Now the simple pendulum, for simple pendulum, if you have seen the diagram, the mass of the bob is ignored, so the size of the bob is very small. Size of the bob is very small compared to that of the length of the wire. So size of the bob of the pendulum is negligible in comparison with the length of the pendulum. So this is a correct statement. The angular amplitude is less than 10 degrees. So what is angular amplitude? Angular amplitude means when you move it like this. Okay, so this angle is, if the angle is less than 10 degree, then we can say that actually this is a straight line motion. We can say this is a straight line motion. Okay, so force is actually negative that of displacement. Otherwise, if you take the complete side, okay, what happens is that displacement in this direction, force in this direction, so you have to take component, and even it is a harmonic motion, it will no longer be a simple harmonic motion. It will no longer be a simple harmonic motion, it will be just a harmonic motion. Okay, so for us pendulum motion to be simple harmonic, it has to be, the angle has to be less than 10 degrees, less than equals to 10 degrees, so that we can say that this motion is almost a straight line motion. Okay, so obviously this is also correct. So both statement 1 and 2 are correct. Both statement 1 and 2 are correct. Next, the displacement of particle executing simple harmonic motion is given by x equals to 3 sine 2 pi t plus pi by 4, where x is in meters and t is in seconds. The amplitude and maximum speed of the particle is. So we know that standard equation of SHM is given by a sine omega t, and if you add a phi that as a phase, it will be standard equation. So if you compare this and this, you will see that the amplitude is 3. Okay, and they ask you the maximum speed of the particle. What is maximum speed of the particle? Maximum speed of the particle is a omega. So if you compare this equation and this equation, you will see that omega is actually 2 pi. Okay, this and this are same, t except t, everything has to be same. So that means a is 3, omega is 2 pi, that means maximum speed is 6 pi. Okay, so 3, 6 pi is the correct answer. Now if you see that all options have 3 meter, I don't know why they have given amplitude. Maybe they just trying to give you a hint that see, all the amplitudes are given same, that means amplitude is 3. Just put that in your mind. If you have forgotten the formula, remember that amplitude is 3. So sometimes they might give some hint like this. Okay, so amplitude is for all the options are same. Okay, just to give you a hint. Now next is, for particle executing simple harmonic motion, its mean position, velocity is 0, acceleration is maximum, velocity is maximum, acceleration is 0. Both velocity acceleration are maximum, both velocity and acceleration are 0. So when a particle executes simple harmonic motion, I always try to take the simple pendulum one. So if the particle is oscillating in a simple harmonic motion, what happens is that at the maximum position, when the particle is at maximum position, okay, the particle momentarily stops. Okay, so particle momentarily stops. Okay, so at this position velocity is 0 and the particle moves because of its acceleration. Okay, so that's why at the extreme position velocity is 0, acceleration is maximum. But in this question they are not asking you about extreme position, they are asking you about mean position. So at the mean position, what happens is that the particle is moving with the maximum speed so that it can reach to the maximum point, and at this point there is no acceleration acting right or left, so acceleration is 0. So at the mean position acceleration is 0, velocity is maximum. Okay, at the extreme position velocity is 0 because it is stopping at that point. It is momentarily stopping at that point. That means its velocity is 0, acceleration is maximum. So here we are finding this point. Now remember, this can be asked in your upcoming exam, so don't forget about this concept as well. So velocity is maximum, acceleration is 0. So correct answer is option B for this question. Now next, the variation of kinetic energy Kx, potential energy Ux and total energy as a function of displacement of a particle in simple harmonic motion as shown in the figure. The value of x0. Now here x0 is this point. The 0 is missing here. Okay, so we know that at this point what happens when these two graphs cross with each other? Cross with each other means they have same coordinate. Same coordinate means what? The value must be same. So at this point potential energy and kinetic energy must be same. When two lines or two curves meet at a point, that means they must have a same value at that point. So that means here they are intersecting, that means kinetic and potential energy is same, and kinetic and potential energy become same at a distance equals to a upon root 2. Here it will be, it is negative axis, so it will be minus a upon root 2. Obviously we are trying to find modulus, so modulus is a upon root 2. and at this position kinetic and potential energy becomes equal. If they ask you a theoretical question, at what distance from the mean position kinetic and potential energy becomes maximum? At a by root 2. Okay, if amplitude is given, you can calculate that even. Now let's move on to the next chapter, waves. And waves chapter, mini question used to come from Doppler effect, which are no longer part of the syllabus, so those questions we are excluding. So let's see. The waves set up in a closed pipe are. So in a closed pipe is basically a organ or sound instrument. Okay, here what happens is that air gets compressed and rarefied. Compression means air gets compressed, and rarefied means it is basically spaced out. Okay, so that means inside a open pipe or closed pipe, any kind of pipe instrument where air is there, okay, it is always sound based device. Sound based device means it always produces longitudinal vibration. It is actually longitudinal and progressive. Okay, sorry, longitudinal and stationary. Okay, so any sound instrument, they always produce stationary wave. Okay, if it is simply air based, they produce longitudinal. If it is solid based, for example, guitar string, sarod string, tanpura string, okay, or Bina string, the strings always produce transverse wave. The strings vibrate like this, okay, and wave propagate in the perpendicular direction. So that's why strings always produces transverse and stationary wave. Whereas pipe, organ pipe, any organ pipe, they always produces longitudinal and stationary wave. So any sound instrument, they are basically based on stationary waves. Okay, now based on whether it's an air or solid, okay, it can produce stationary, it can produce longitudinal or transverse. Solid generally produce transverse. Now next, first overtone frequency of a closed pipe of length L1 equal to second harmonic frequency of open pipe of length L2, then the ratio of L1 and L2. Now here you have to remember that overtone, okay, overtone means the second highest frequency. For a one side closed pipe, closed pipe always produces odd harmonics. Okay, closed pipe always produces odd harmonics. That means the overtone frequency of the closed pipe must be the second one. So after 1, 2 is missing, so the first overtone will be 3. Okay, for closed pipe, okay, first overtone is equals to n equals to 3, that is third harmonic. For open pipe, if the same question is asked with open pipe first harmonic will be 2. Okay, harmonics, not first harmonic, sorry, overtone, first overtone will be n equals to 2. Overtone means the next in the line. Okay, next, who is next in the line? N equals to 1, then n equals to 3. Okay, closed pipe always produces odd frequencies. Now what is the frequency for closed pipe? So frequency for closed pipe, let me not write F. Frequency for closed pipe, okay, it is given by the harmonic number, okay, into V divided by 4L. Okay, suppose this is L1 given in the question. Okay, so for closed pipe frequency is NV by L1, 4L1, and for open pipe the frequency is N, suppose this is N closed, this is N open, V of speed of sound is same, okay, divided by 2L2. Okay, now let's put the values. So basically they are producing same frequencies means obviously they has to be equal. So number of closed into V divided by 4L1 equals to number of open into V by 2L2. So V cancels. Now put the values. For closed pipe, as I mentioned, it is first overtone. So first overtone is n equals to 3 divided by 4L1, and in the second case it is already mentioned second harmonic, so NO equals to already 2 mentioned in the question. So 2 by 2 L2. Now I know harmonics, frequency, overtone can be confusing. Okay, harmonics are easier, obviously the number itself represents everything, but in case of overtone it can be confusing. Okay, so it is so what is L1 by L2? So L1 by L2 equals to 3 by 4. Okay, this goes over here. Okay, cross multiplication, 3 by 4 remains as it is. So L1 by L2 is 3 by 4. So it is 3 by 4. Option A is correct. Okay, now let's move on to the next question. The equation of stationary wave y equals to 2 sine pi x by 15 cos 48 pi t. Okay, so here the distance between node and next antinode. Now I also mentioned the formula for stationary wave wrong, so I like to correct it. Normal equation for stationary wave is given by A sine kx into cos omega t. Okay, this is the expression for a general stationary wave. I mentioned kx minus omega t, which is not wrong, which is wrong because it's stationary, so it is not vibrating, so there is no minus omega t term over here. Okay, so it will be simply kx and cos omega t. So from here we can say that what is the value of k. If you compare that, the value of k must be this one. Okay, this is with x, so k is given by pi by 15. Now from there we can calculate the wavelength. Wavelength is given by 2 pi upon k, that is 2 pi divided by pi by 15, that is 30. So lambda is 30. Okay, now what is a stationary wave? Stationary wave is one wave is like this and another wave coming in the opposite direction and they overlap. Okay, one is coming from this side, another one is coming from that side, and they overlap. Okay, and they produce this is called antinode, this is called node, this is antinode, this is node. Okay, now if you see that this is the, if you consider this is the starting point, then this total distance is actually wavelength lambda, right? Or you can take, okay, this I want to take this one is wavelength lambda, right? Consecutive crests, this is the second wave, this one is the second wave. Let me use a second color for that, okay, so that you don't get confused. So let me use a second color for this one. I hope this will be clear now. Okay, so the wavelength is actually distance between two consecutive crests or consecutive troughs. Troughs means the bottom one is called troughs. So this one and the next one, whatever it is coming. So this total length is lambda. Okay, they ask you the distance between antinode and node. That is, they ask you this distance. What is this distance? So obviously this total distance is lambda, so this must be the midpoint, so it will be lambda by 2. This is midpoint of midpoint, so it must be lambda by 4. Now remember, the distance between node and antinode is always lambda by 4. Distance between two consecutive node is lambda by 2. Distance between two consecutive antinode will be again lambda by 2. Antinode means this and this, node means this and this. Okay, so node means if two consecutive node you are taking, it will be lambda by 2. Two consecutive antinode if you are taking, again it will be lambda by 2. But between a node and antinode it will be lambda by 4. So lambda we have calculated. So distance between consecutive node and one antinode and node is antinode and node is lambda by 4, which is 30 by 4, which will be 7.5. Okay, so it will be 7.5 units. Correct answer is option B. Now, next question. To propagate both longitudinal and transverse waves, a material must have. So longitudinal means obviously compression and rarefication of gases. Okay, compression, so gas molecules compress, and rarefication means gas molecules expand. So basically in longitudinal wave, the wave propagates like this. The particles are also vibrating like this. Okay, some point everyone comes closer it gives you a compressed region, and sometimes they all go further apart, giving you rarefication. Rarefication means, rare means what? Rare means not available easily. So rarefication means they go further away, so their distance increases, so they do not see each other regularly. So that's why it is called rarefication. And compression, obviously the name suggests, compression is the gas molecules, they come closer. So basically what happens is that the gas is compressing and expanding, compressing and expanding. Compressing and expanding happens through what? By volume. Okay, so volume can be compressed and expanded, so that means it must have a bulk modulus. Okay, hydraulic modulus. Okay, hydraulic compression. So compression of volume is called hydraulics, right? Hydraulic compression. So the pressure is changing, so it must be bulk modulus. So always remember, for a longitudinal wave, bulk modulus is essential. Okay, this is for longitudinal, right? And that for that we need bulk. Now for transverse wave, suppose this is a stretched string. For a string we always see transverse wave. What happens? The particles vibrate in the perpendicular direction like this, and because of that, what happens is that the overall tension of the string remains same. Okay, overall tension of the string remains same. That means the overall length of the string remains same. They vibrate very tiny. Okay, not this huge as I shown in this picture. Okay, their vibration is very tiny. If you have seen someone playing guitar or any musical instrument, any string based instrument, you do not see the strings vibrate. You can feel it if you touch it. Otherwise they vibrate very little, right? So their tension remains same, their length remains same, so longitudinal stress remains same. Okay, that means there is no requirement of Young's modulus, but because you are changing it, applying some force on it, okay, in the parallel direction or tangential direction, okay, that means it requires a shearing modulus. Okay, it requires a shearing modulus. So correct answer for transverse, obviously the force is tangential. Tangential means in this direction. Okay, so it must require shearing modulus or shear modulus. Okay, so that means we require longitudinal and shear moduli both for propagating longitudinal and transverse waves. Okay, bulk and shear modulus both. Next question. The angle between, I think this is the last question, the angle between particle velocity and wave velocity in a transverse wave. So in a transverse wave, as I mentioned, particles vibrate in this direction and the wave propagate in the perpendicular direction. Any example? Light wave. Okay, light wave is an example. The string that I have shown, the particles are vibrating like this. This sound wave propagate in the perpendicular direction. So in transverse direction, for transverse wave, okay, for transverse, okay, the angle is 90 degrees or pi by 2. For longitudinal, where the wave is propagating, the particle is vibrating in the in the parallel direction. In this case, the angle is 0 degree for longitudinal. Okay, longitudinal it is 0 degrees. For transverse wave it is pi by 2 or 90 degrees. Okay, so theta is pi by 2 or 90 degrees. For longitudinal, theta is 0 degrees. So here answer is pi by 2 radian. Now as I mentioned from the wave chapter, the concept of Doppler effect is now deleted. Based on that, a lot of questions came in the past. That concept you do not need to study. If you see in a PYQ book those questions are there, definitely you can ignore that because they are not part of the syllabus. Okay, so this is the end of today's lecture. I hope you enjoyed it. This is the end of the PU1 lecture series as well. We will meet you in the next live class. We will discuss all of your PU1 doubts, and then we will move on to our PU2 syllabus lectures. Syllabus lecture, the theory lecture is already available to you. We will be getting the PYQ lectures, and also we will be discussing more and more during our live class. And before till the next class, bye. See you in the next class.